So 8.5, change of base. That's our discussion topic for today. Let me give you guys a little background information about what we're doing and why we're doing it. First off, we have done equations like this in the past. We've been trying to solve exponential equations, kind of like this. So maybe you guys can help refresh our memories here. How do we solve a problem like this? What do we do? No. What we're going to do first is we want both sides to be the same base. So I'm going to change 25 into 5 to the second power. And then, after that, what do we do? Since the base is the same, you can cross it off, right? And we have our answer. But we could very well run into this circumstance. There's an answer to this question, but now what? You got a little bit of a problem. You can't write 11 as 5 to a power. So what we're going to learn today is how to change the bases, and we're going to do that using logs today, all right? So that's the purpose of today, so we can solve those equations, but we're going to need our calculators for that. So that's why I told you guys to bring your calculators. And if you guys can see here, what's 5 to the first power?
5.
That equals 5, right? What's 5 to the second power? 25. So, question mark. I need to know 5 to what power would give me 11, because it's got to be between the 5 and the 25 there. So what goes in the middle there so that 5 to what power would give me 11? It's got to be between my two exponents, 1 and 2, right? So that's what we got to figure out. It's going to be a decimal answer. All right, so let's go ahead and see how we're going to do that. So today's topic is to use change of base for logarithms and how to solve equations like the one I just gave you using that change of base. All right? So before we actually do it, I'm going to show you how they got the formula, okay? Let me go ahead and switch slides here again. And I'm thinking about maybe making this proof an extra credit question on your test. So if you want to write down the proof, it might be a good thing to look at. So let's suppose that we had this log. Now I'm not going to write it in exponential form. I'm going to write it in log form. Suppose that I had this. But I don't like it being in base A. I want it to be in another base that I'm more familiar with. And by the way, the base we're going to use today is 10 because that's the base our calculator works with. So let's just say I want that to be in another base. Well, the first thing we're going to do is I'm going to make it equal something. I'm going to make it equal y. And I'm going to change it to exponential form. So in exponential form, what would that be? Yeah, left, right, middle. So it would be a to the y equals x. Now, here's where the new base comes in. I'm going to pick a new random base. So I'm just going to call the base b. Okay, it could be any base I want. I don't want it to be a anymore. I want it to be b. So what I'm going to do is I'm going to take the log base b on both sides. Sorry, that's a little messy. Let me rewrite that one. There. Well, now I've got a new log in there. Now remember, I'm trying to figure out what this would be in base b. So I just need to get y by itself. And if I've got y by itself, then I can do it. So how can I get this y out of here? Yeah, we can use the law of logs. It says that exponents become multipliers, right? So now I have this. Log times log base b of a equals log base b of x. Now how can I get the y by itself? No, we can't cross the log off because in order to do that you need one log on both sides to do that. And this y is in the front, which means I have y log minus log b's down there. So we can't just cross the log off. But let me give you a hint. It's y times the log. So how can I get the y by itself? By dividing it out. So I can divide this side by log base b of a. So they cancel. But whatever one you do to one side, you must do to the other. Base b of a. So there it is. Y equals this. So since y equals log base b of x over log base b of a, I can just replace my y up here with that value. And there's your change of base formula. This is the formula. So now these two sides are equal to each other, right? But this one has a base what? This one has base b. So I successfully changed the base to what I wanted. Now we're not going to use base b, we're going to use base 10 today, but that's basically it. Now you don't have to derive this every time, but what you're going to do is we're just going to use that formula. So basically if you want to change the bases, you just do the log base of whatever of x and then log base whatever of a, and you divide them. Now if that was all crazy to you and you don't get it, you don't have to know it. Like I said, it's just an extra credit question. That's not what I'm requiring you to know today, but I do want you to know how to use that formula to get an answer. So that's what we're going to be focusing on. So how can we write log base a of x in terms of log base b of b? With that formula. So go ahead and write down the title. That's the title of this formula. And then write down the formula itself. So let's proceed. Go ahead and write down your directions and number 1. Alright. Now before, when we approached this type of problem, we would first of all make it equal x, right? You don't need to write this for now. I'm just kind of giving you guys a little heads up. We would make it equal x. Then we would change it to exponential form, which would be 5 to the x equals 10. But right there you're going to run into a problem because I can't find a way to make 10 into 5 to a power. Okay? 5 to the first power is 1, 5 to the second is 25, so we skip it. It's some sort of decimal between 1 and 2, and I don't know what it is. So we need to do change of base so that we're not in that base 5 anymore that we can't use. So here we go. The first thing we're going to do is the change of base formula. So here's how it works. You're going to have log base 10, because we're going to use 10 because that's what's on our calculators. And our calculator can do that for us. So log base 10, but we're going to have something on the top and something on the bottom. What goes on the top?
Log base 10.
The 10, right? This number goes on the top. And the base number, the 5, the old base number that is, goes on the bottom. So we're going to do log base 10 of 10 and log base 10 of 5. So what is log base 10 of 10? Now we could do that in our heads, hopefully. That's 1. Anytime the base matches that number, then it's 1. So that one we don't need to do any calculator work for. But for the bottom, we do need to use our calculators. So your calculators are usually set in log base 10 already. Now some people's calculators, you have to push log first and then 5, and then enter or equals. Some people you have to push 5 first and then the log. So you guys go ahead and experiment with it, but here's what you should be getting. I'm going to be rounding to the hundredths place, so you should be getting about 0.70 actually, 0.7, because I'm going to round to the hundredths place. So go ahead and try it, and if you're not getting that, then talk with some neighbors or raise your hand. We have one more thing to do to finish up. And what we're going to do now is we're going to divide the top number by the bottom number. So on your calculators, guys, go ahead and do 1 divided by 0.7 and see what you get. I'm going to put my answer up. So I'm getting 1.43. So let's see what it was we actually found. Now that's our answer. You're done with this problem, but I want you guys to know what we found. I don't want it to be just some random number. So what was our answer for this? It came out to be what? Let me show you what I just found. What I just found was what power I need to raise 5 to get 10. And didn't I say it was going to be between 1 and 2? And check it out. 1.43 is between 1 and 2. Watch, I'll show you. Change it to exponential form. It'd be 5 to the 1.43 equals 10. You guys are like, well, how do I know that's true? Well, guess what? You got a calculator. So go ahead and on your calculator, if you know how to do it, usually it looks like a little upside down arrow or something. Do 5 to the power of 1.43 and see what you get. Now I'm getting from mine something like 9.98. Well, that's not equal to 10, right? But it's pretty darn close. And the reason why it's not exact is because we rounded, okay? So there's that. All right, so after all that big, long discussion on number 1, we're just going to stick to the basic idea of what we're doing here on number 2. So let's do it. First thing we're going to do is we're going to do the change of base. So it's going to be log. What am I going to take the log of on the top? 7. And on the bottom? 3. Okay. Let's go ahead and figure out what log of 7 is first. Rounding to the hundredths place. And I'm getting 0.85, so. And on the bottom, I'm going to get 0.48. And then I'm going to divide. And I'm getting 1.77, which is about the same thing as 1.8. There you go. Now, real quick though, can somebody interpret that answer for me? What did I just find?
You just found the power that 3 has to be raised to equal 7.
There you go. If you raise 3 to the power of 1.77, you should get 7. So I'm finding an exponent is what I'm finding. All right, go ahead and write down number 3, please. All right, here we go. Now, Destiny asked a good question, and let's answer it. Notice I didn't put the base 10 because I had a little note down here. From now on, if it's base 10, I'm probably just not going to write it because log base 10 is the standard base, and so if I just put log, we can all know that that means log base 10, okay? So let's do one more problem here, number 3. It's going to be log of 9 over log of 2, and we'll get our answer. So it's 3.17.